Okay, here are some examples for practice with using interior and exterior angles in circles. This is in section 10.6 if you want to refer to additional examples in your textbook. First two examples are using our interior angle theorem, which tells us that the angle measure is equal to half of the sum of the two arcs. We did say that it's the average of the arcs. So first one, very straightforward. X is equal to 74 plus 22. Those are my two arcs. Divided by 2, or you could say 1/2 of 74 plus 22. And that's giving me x is 96 divided by 2 for an answer of 48 degrees. Second one, notice the difference between 1 and 2. In number 2, my x is no longer my angle. My x is one of my arcs. So just be careful when you set this up. We're always going to go angle equals arc plus arc divided by 2. So my angle is 80 degrees is equal to my arc. One of the arcs is x, the other one is 45. It doesn't matter, by the way, what order those go in, you're adding them, so you can switch divided by 2. And this one's going to involve a little bit more algebra. Some of you might just do guess and check, and that'll work as well. I prefer the algebra just to get my answer quicker. So I am going to multiply both sides by 2, get rid of the denominator, and I get 160 is equal to x plus 45, subtract the 45, and my answer is x is equal to 115 degrees. You can do a real quick double check, plug it back in. 115 plus 45 divided by 2 better be giving you your 80-degree interior angle. So that's really both examples, both cases you could have with an interior angle. Either you're solving for the angle or you're solving for one of the arcs. Now let's look at exterior angles. And feel free, by the way, to pause the video at any point if you want to try them on your own and see how you do. The difference with my exterior angle theorem is that I'm subtracting the arcs instead of dividing or instead of adding them. I still need to find the two arcs. So if I'm looking for this angle here, I need to find the two arcs inside that angle, the two arcs of the circle being cut off by the angle, the other way to think of it. I know one of them is 20 degrees, that's my smaller arc here. And it doesn't appear that I know this arc. I need that to plug in my formula. So the first thing I need to ask myself is how do I find that arc? Remember that these, however many arcs you have in your circle, all of the arcs have to add up to 360. So I'm going to do a quick 130 plus 20 plus 75, add up those arcs. And that's going to give me 225. And when I do 360 minus 225, I'm going to end up with 135 degrees for this arc right here. Okay, so that was a little preliminary work. Now I'm ready to use my exterior angle theorem for angles. Angle is equal to arc minus arc divided by 2. And in this case, I like to say big arc minus little arc. You're going the arc furthest away from the angle. So I'm going to start with the 135 minus the little arc, which is the one closest to the angle, which is 20 in this case, and dividing that by 2. If you switch the order of those, the only thing that's going to happen is you're going to end up with a negative answer, which doesn't make sense for an angle. You're going to have the same value, and you can just use that. Final answer, 115 divided by 2. Make sure you are using parentheses when you're typing this in your calculator, or actually doing the numerator and then dividing by 2. Otherwise, your calculator is going to do 20 divided by 2. Subtract that from 135, which is not what we're going for here. Final answer I'm getting is 57.5 degrees. An angle can be a decimal. That's okay. And we just found the measure of this angle over here, exterior angle. Number 4, variation of the exterior angle theorem. We said instead of having 2 secants, we could have 2 tangents, and that's what we have in this case. So my angle is what I'm looking for still. My angle is equal to arc minus arc. I'm looking for the big arc. Don't know that one, but I do know my little arc is 132 here, my inside arc. So again, I'm going to have to do some preliminary work to figure out that blue arc. What is my big arc? And in this case, I just have 2 arcs making my circle. So I'm going to do 360 minus my 132. because together the two arcs actually complete the entire circle, and that's giving me 228 degrees. So I'm putting my 228 in for my big arc, I'm subtracting, dividing by 2, and I got an answer of 48 degrees. Check your work and see if you get the same thing. Two more examples with exterior angles, and I think you'll be good to go. The fifth one is the third case of an exterior angle in terms of the picture. I've got a tangent and a secant instead of two secants or two tangents. And the real reason I want to do this one is not so much the picture. In this one, we are solving for the arc and not the angle. So this is going to be a backwards case. I'm going to take you back to number 2 that we did and say we're going to do a similar process where we're actually looking for our arc, and it's not just a plug and chug. You're going to have to do some algebra. Okay, let's tackle it. My angle is 40 degrees. So 40 is equal to big arc. That's my angle over here. I know it this time. Big arc, which is 130, minus my little arc is my x in this case, divided by 2. So that should be your setup. Now it's just some algebra from here. So let's do the algebra. First thing I'm going to do, and I would say in this case, make sure that you get them in the right order, the big arc and the little arc. It did need to be 130 minus x. Algebra, I'm going to multiply both sides by 2. Get rid of the 2. I get 80 equals 130 minus x. Either subtract your 130 or add x and then subtract 80, and you should be getting 50 degrees for our angle measure there. Or I mean our arc measure, sorry. Again, if you want to plug it in, do a quick check, 130 minus 50 divided by 2, and you're going to end up with 40 degrees. 6 would be a multi-step question, and this will get you ready for Monday. We're going to put them all together. That's what's coming next. So we've got, I'm going to start with the exterior angle, because that's my x, is equal to arc minus arc divided by 2, big arc 90, little arc. Inside, don't know it, so I need to find it. Preliminary work, I'm looking at the other arcs in the circle. I know 90. I do not know this arc here. I need to know that to complete the circle and figure out what my green arc would be. So I'm going to somehow use this 120 to figure out what this arc is, because that would be the angle that has that purple arc inside of it. Now you're asking yourself, what kind of an angle is that? Is that a central angle, inscribed, interior, or exterior? You now have 4 angle types in terms of your circle. And hopefully you are answering that question with the term inscribed angle, because my vertex is on the circle. Inscribed angle, recall, is half of your arc measure, the intercepted arc. So if my angle is 120, my arc is 240 degrees. Now I can go ahead and do 240 plus 90 and get 330. Whoops, that was supposed to be 330. And then go ahead and do 360 minus 330 to give me 30 degrees for that green arc. Now I'm set up to go back to my exterior angle theorem. Angle is equal to arc minus arc divided by 2. And now I'm just looking at this angle. And this is one of those where you don't have to do the algebra, just do the math. 90 minus 30, giving me 60 divided by 2 for an answer of 30 degrees for my exterior angle. I think that completes it, and that'll give you a great start on dealing with interior and exterior angles. So go ahead and try some on your own. Good luck.